again to this new session of Ubidots Live. Today we're going to talk about the updates in our particle library to integrate particle mesh boards. Today I have with me Jose, our hardware and software engineer leader, who is the one who is the author and maintainer of our incredible particle library. And also I am with David, as you already know, our IoT specialist, and myself, Maria, IoT developer advocate at Ubidots. Guys, remember that this is the best place for you to ask any question that you can have. Don't hesitate in leave your question in the comment section of the live session. So
you are giving us the word. So yeah, as usual, guys. Yeah, I'm David, IoT specialist here in Ubidots. Jose, he's also been here sharing with us his incredible knowledge. And now we are going to talk about the new release for particle mesh devices. We are extending the support for this library to make it easier to integrate this new family of devices. So with anything else on the table for me, I would like to give the word to Jose, who is going to introduce us. This is going to be rather a quick introduction to the particle new release. I just want to tell you guys that it's not yet released. It's going to be a
release candidate.
Because we are still working on some little details, and just to let you know that right now we are only forwarding data from devices to Ubidots. We still have a lot of work to do the backwards direction, that is from Ubidots to the devices, any gateway or the endpoints for control purposes. So yeah, Jose.
Okay.
Give it up.
Cool. Let me change the screen. And guys, just a quick reminder for you, at the end of the session, we're going to be providing a coupon code that you can claim to get your free month on Ubidots for free. So keep that in mind. So and stay during all the live sessions. So Jose, here you go.
So let's talk about what is mesh. So
yeah,
I think that
definitely.
Before showing some samples, we need to know what mesh is, what particle mesh is. Yeah. So basically, it's like a local network. It's like a local network which you have nodes and gateways. You can have several nodes and several gateways. But the only device that gives you outside to the cloud is a gateway. Internet connection is a gateway. Yeah. So basically, the main idea is that you have different nodes in different places. Yeah, the nodes must be near, obviously, because the mesh has a limited range.
Yeah.
But it's a network where every node communicates with every node,
yep,
and also with every gateway in the whole network.
That's great.
Yeah.
Can you explain us a little bit from the architecture in that image? I think it will be
basically we have a xenon, a particle xenon. The particle xenon is the node mesh. Particle xenon is just a node. But also we have particle argon and particle boron, which are not only nodes but gateways. Yeah.
And what is the difference between the argon and the boron?
Okay, the argon give us cloud communication through Wi-Fi.
Yep.
And the boron give us communication through LTE.
LTE.
Yeah?
I think the boron also supports 2G and 3G. There is a version for those standards.
Yeah, there is also it's like a cellular
gateway.
Yeah, it's like the electron, but with mesh.
With mesh, yeah.
Okay.
And
something like
same
that.
goes to argon. It's like the photon device, but with mesh connectivity. Okay.
The mesh is a proprietary protocol from Particle. It's based on another open source protocol. And basically, you have the node. In this case, the xenon. The xenon may read different stuff from sensors, and using particle mesh, the xenon can send those data, anything that he reads, to any node or any gateway in the same mesh network.
Yeah.
Okay.
So you just need to subscribe using a node or using a gateway to a channel in the mesh network, and in that way you can listen any message, any packet from any device or any node.
It's
in the
very
mesh.
related to what it would be MQTT. You
Yeah.
publish to an event that it would be a topic, and then you hear from another device, or forward data to the cloud using a gateway.
And
of
also
course.
you can subscribe to.
Yeah, you can subscribe to any channel on your mesh network.
The limitation here is that in MQTT you can subscribe to
Yeah, to any amount of
any
channels.
amount of channels. In mesh you can subscribe to add 5 channels. That's the limitation.
That's the maximum.
That's
Just
the
five?
maximum- Just 5. Just
Okay.
the maximum number of channels that you can subscribe using particle mesh.
That's
And also the packet size. So
Yeah,
in
that's really
MQTT we don't have any limitation on the packet size.
Okay.
With particle mesh, the packet size, the maximum of bytes that we can use is 256.
256. Yeah, that's
the,
correct.
the max length of the packet in particle mesh. So that gives us some limitations that we need to keep in mind when.
Yeah,
when
we're
we
going to
make-
see those limitations in the examples.
Yeah.
We're going to be really
I have a
valid.
question.
Yeah.
How these devices manage the battery life?
Usually, both boron and xenon are not devices
Battery
Battery life,
for long
yeah.
battery life.
Exactly.
Yeah?
Because are gateways.
But particle give us some methods to make longer that battery life, because with particle we can go in deep sleep modes. So particle give us some ways to make interruptions to wake the device when he's in
Yeah.
deep sleep.
Exactly.
I read a post from Particle explaining all the mesh connectivity and the release, and they say that the gateway is not supposed to work under a battery.
Yeah, no.
Yeah,
because
it needs
it's
a
gateway.
power supply,
Yeah.
a constant power supply, because he's always listening. The only devices that should go to idle mode is the Xenon.
The
The
Xenon
Xenon.
one.
You can even have Xenon as repeaters. It's
Yeah.
just like a rotor.
Okay.
Yeah.
Those cannot either have battery power life. They need to be always constantly, because they are going to strain the mesh network and forward packages. So if they go to idle mode, packages are going to be whether lost or the strength of the network is going to be compromised.
Yeah.
So
The more nodes that you have, the more strength
the more strength
the,
on
the
the
network is.
Yeah.
Okay.
So that's the main idea of the new protocol. Because with mesh you can only communicate nodes in locally. You don't have any output to the network. So you need to have many nodes. That's the ideal way to implement this. And also 1 or 2 gateways, because any gateway listening to the channel
can forward the data.
the data
Actually,
to uBeDots.
Let
So
me-
the first gateway that receives the data is the one in charge of sending
Yeah.
data. Okay.
Let me step to the particles. They have an image here really quickly to show you guys, and it's really illustrate.
Give me.
The other way around. Yep.
No, but
I'm
one-
sorry.
Wait a
I'm sorry. I'm
Yeah.
sorry.
Okay.
Yeah, that was my fault. I know the image is some way here. If it's not, I'm going to make sure to add it to the article.
I think it's not.
I think it's not. Yeah, that was my bad. Just a quick around again. Nope. Yeah, my bad. So Jose, what do you think if we step in?
Okay, so let's have clear the main architecture. We have a node or nodes, any amount of nodes. In
So-
this case, we have a particle xenon,
Particle xenon. Yep. Here it is.
and we also have a gateway.
Yeah,
In
of
this
course.
case, we are using an argon, which have Wi-Fi communication.
Communication.
So the xenon reads, in this case, any sensor. In this case, and just sending a fixed value from the xenon.
It's actually not fixed. It's
I'm reading
analog port.
Analog port,
but
yeah, but it's not
as-
reading any
as
sensor.
This have any sensor, so
Yeah.
it will
Yeah.
be a fixed value. So the xenon will send the value using particle mesh to this one,
Gateway.
and the gateway will use any of those protocols that is supported by uBeDots, HTTP, TCP, UDP, and webhooks to send the value from the xenon to uBeDots.
Yeah.
So that's the life cycle of the dot.
Yeah.
From xenon using particle mesh to the gateway, and from the gateway using any available IoT protocol to the
To
cloud,
uBeDots.
to uBeDots.
Yeah.
So that's the main idea. So let's see how we make this Yeah.
Yeah.
So as we have in this case two different kind of devices,
Yeah.
the gateway and the node.
Mhm.
Yeah. So we need to upload a different kind of two different firmwares to those two
To
devices.
each device.
Yeah.
To each device. Yeah.
Mhm.
Because the Argon is going to handle some code. He's going to handle all the mesh connectivity and forwarding to uBeDots. Whereas the Xenon is only going to read an analog port or handle its sensors and
And
then
send it
forward
to the-
through mesh
Yeah.
network to the gateway. So you're going to have two separate codes.
Two
That is
separate
really
codes.
important.
That's really important to understand
Yeah.
because even the Argon would be also a node.
Yeah,
Can
it
be.
could be a node. Yeah.
Yeah, it can be a node, and you can have another Argon to send data,
Mhm.
and
Okay.
that's perfectly fine
Mhm.
because the architecture
Allows
allows me
us.
to do that.
Mhm.
Yeah. So in our actual library we have 4 protocols: TCP, UDP, HTTP, and protocol webhooks.
Yep.
And we select which protocol we wish to manage just in the constructor. Yeah.
That was previously, right?
That was previously.
Previously.
So now for this new release, we are going to have another lower protocol,
Mhm.
which is uBeMesh.
Yeah.
Yeah. uBeMesh is the way that I can say to the devices that I'm going to upload some mesh stuff.
Mhm.
I don't know what kind of mesh because that the library makes that in the background.
Mhm.
But for the user is that I'm going to program or a mesh device. Yeah. So
what it will happen? What happen if I put the uBeMesh flag and then I try to compile against a photon or an electron?
okay, you should not get any error for compiling,
Uh-huh.
but you will get some warnings in your server port, and the
Okay.
forum will not make anything. Yeah,
Okay.
you may call from the forum these methods,
Mhm.
Okay.
all the mesh methods, but
That's
they
not
will
going to
not
do
make
anything.
anything
Yeah.
because it
Okay.
makes no sense.
Okay.
Yeah?
Yeah.
It makes
Great.
no sense to make something like something for mesh using forum
Yeah, but
or electron.
Yeah.
That's good to know because, I mean, it's good to know that the hardware is not going to break down
Yeah.
when compiling. But okay, yeah.
Yeah,
great.
that's very important, and it's also important to know that even if you have the debug set to false,
Mhm.
and you try to use a photon or an electron using any mesh,
Yeah.
You are going to still
you
have those
are going
messages.
to still have
Great.
those messages because that's warning message.
Mhm.
It's
Exactly.
telling to you that you are not using properly the
Okay,
library.
the library.
Yeah?
Great.
So in this case, look, that is very similar to the actual firmware example that we have in our after library.
Uh-huh.
So we have just 2 additional methods in this
Mhm.
case. So the first method is this one, set cloud protocol.
Mhm.
So if I'm using a gateway, I need to tell to the gateway which protocol I wish to use to send data that is coming from mesh.
Mhm.
Yeah.
Okay.
So the default method, the default cloud method in this case, is uBTCP. That's the default method.
Mhm.
But I can also use here uBTCP or uBHTTP
Or UDP.
UDP or particle webhooks.
Oh, with particle. Yeah.
And the second additional method is this one,
Mhm.
mesh loop. The
Yeah.
mesh loop is the one that handles the mesh connection
Yeah.
of the device.
Let's make this on the setting on the screen. Here is what Jose is referring to. This method.
Yeah.
Mesh loop. Can you explain us what is going to do that?
Okay, so as I said at the beginning, the mesh network, you subscribe to a channel.
Yeah.
So in the background we have a custom Ubidots channel.
Mhm.
Yeah. So the mesh loop handles that connection.
Yeah.
If the mesh network goes down,
Mhm.
then the mesh loop the mesh loop makes that once the mesh network comes up again,
Uh-huh.
Okay.
I subscribe to that custom
To that custom
to
channel.
that custom channel.
So every I mean what you said at the beginning is that every mesh capable device is going to handle at maximum 5 channels.
Yeah.
We just reserve one for uBeDots
We
right now.
reserve one for Ubidots.
So if you use uBeDots library, you only have 4 left
Yeah.
to do as you wish.
Mhm.
Yeah, but please note that once you add uBeDots library for mesh devices, you're going to have one less channel available.
One less channel. That's very important to have to keep in mind, because even if you subscribe in your custom firmware to an additional 5 new channels, the mesh loop will
override
that.
So you're only going to have 4 mesh loops, 4 mesh additional subscribers. And that's it.
That's very important to know.
That's great.
So this is the framework for the gateway. Look, that it's very simple. In this case, the gateway is not reading any sensor. It's just acting like
a gateway. A literal gateway. He's only forwarding data from the mesh network to uBeDots. Okay, that's great.
So let's see now about the node. How do we what do we make in the node? So it's the same constructor. I'm using UBmesh. I'm reading, like always, an analog analog ping, and I'm using the typical uBeDots method, that is add. So here is another new change. Usually with TCP, UDP, and HTTP, you can add up to 10 variables.
Up to 10.
But in this case, due to the mesh limitation of 256 bytes, you can add as
only one variable.
Only one variable. But if I make this, for example, if I wish to, if I add here an additional variable, the library will only send the last one. That's very important to
So in case that someone wants to send 2 variables, he has to send the add value, then the mesh publish, and then repeat again.
We're going to do that just in a second.
Okay,
but
cool.
Let's start by the simple example.
Perfect.
This is the simplest one. So I add the variable and I add the value, and I use this new method, which is mesh publish to uBeDots. So this method has as arguments the device label and the device name, but you can also just
leave it blank.
Leave it blank, because in this way the node will publish as device its particular device ID. So the device at uBeDots will be the custom node particular device ID.
Okay.
So this is like a production.
It's better. Actually, we always advise to all users to use particle ID because they already did the job to give you a unique identifier, so you can
per device.
So there is no way you mess up with that. I mean, there is no way you are going to create 2 devices and then, I mean, that will be a hell.
And
many devices with the same device label are going to report to the same, and you don't know which data is which. So using particle ID, that means leaving the mesh published to uBeDots blank is going to ensure to use that ID as a device label on uBeDots. We are going to see that just in a minute.
So let's look at that. I'm going just to compile this one, and I'm going to upload that to the Xenon. This one is the Xenon.
This is the one.
Here, just a quick question from Carlos Figueroa. Where are the nodes? What are the nodes? Any device connected to the network?
Any device connected to the network is considered a node. But the Xenon can be, the Xenon is only node. The Xenon cannot be gateway. Argon and Boron are both nodes and gateways.
Perfect.
That's ready.
Okay,
so flash successful. Here is, it's already connected.
Okay,
so we're going to do our account, the monitor. That's better.
Sorry. I'm not sure which port is.
We have a new one. I know, it's the same age.
I don't know. Actually, I don't know. Let's try them all. We don't have any other choice.
So this device is sending every 20 seconds. So
that is really important.
20 seconds?
Yeah, because
we have noticed, or Jose told me just this morning, that sending data with a bigger period, something like every 5 seconds, might cause
bigger or less?
A very high sample rate makes
less than 5
the
seconds.
device
Makes the Argon device, the gateway device, to crash because sometimes there are queue messages, and he starts queue them on its memory. So once the memory is
Basically, particle mesh, what makes is I send a message and I have a handler for that message, and I created an instance for sending data. So a message arrives, a message that I send, but if the message from the particle mesh is faster than the message that I deliver, so I have a problem.
Yeah, you have a queue.
I have a queue. So if the queue is filled, so
it's filled. Yeah.
Yeah, the mesh have a problem. In this case, that's why I'm sending data every 20 seconds. So in this case, I can see that. Let me show you. I don't know if I can make this bigger. No. So for you guys, I am published to this custom channel, which is uBeMesh.
Okay.
That's the custom particle mesh channel that we use, and I'm just printing what is coming from the particle mesh. So in this case, I'm receiving the particle ID from the Xenon, not from the gateway. It's from the Xenon, and I'm receiving the variable label, which is variable label, and the value, which is this one. That is what I'm reading in this case from the A0 analog pin. I'm not receiving anything else, but I also may add here a context. I also may add here a custom timestamp, like usually you do with the actual add method. So those kind of operations are also supported in this library. So cool. Let's see if we are receiving also the data. Here I have the custom device. Just put here Xenon, Facebook Live.
To make it clear, you can check. I mean, uBeDots is something I received many questions about this. uBeDots devices have 3 identifiers. One is the name, that is just for visualization purposes. Then the API label, which is in this case particle ID, and then every device has an ID. This is automatically created by uBeDots. It cannot be changed. So you have the 3 identifiers. Usually we always refer to the API label, because this one is you are able to change it. And go on.
So in this case, look that the API label is the same that I'm using here from as device label. It's the same. So that is because I'm not setting anything in this method. But I can put here my custom device, and I will, in this way, it will publish to a new device, labeled as my custom device. But in this case, just to make the Facebook Live simpler, just
leave it like that. Okay.
So what happened if I
can we see the data? I mean, I would like to see the data on uBeDots.
The data is
variable
here.
label. And there you go.
Look at it's almost every 20 seconds, more or less.
Also, we have another question from Carlos too. Which are the recommended times to make the poll?
So actually, we are performing some tests to have that particular value clear, but it will be already documented in the at the GitHub library. So right now, 20 seconds has proven to be a nice value, but I need to make an additional improvement to the library to make that number lower.
Actually, what you told me this morning is you're not going to queue messages. I mean, if the memory is going full, you delete it.
So that's the decision that we are analyzing. If it's better to just lose packets and to publish every 1 second or every 2 seconds, but that I can make sure that the time I can publish from any node. To ensure that.
What else do you have on the package?
So
an example here.
Let's look what happened if I make this. If I add an additional variable label, in this case variable label 2, and I send the same value, but look that I'm adding two variables. So in this case the library will publish just to this one. Why? Because I have only 256 bytes to use in mesh. So just for reference purposes, just upload this code.
right now compiled. Yeah, it's ready, and then I thought it was ready.
It says
No.
ready. No,
Yeah.
great work.
Sometimes it takes.
Yeah, it takes
A little
longer.
bit. Yeah.
So actually, this is really easy, guys.
Yeah. And how you compare, like you are the one who made like all the library.
Yeah.
How you compare like this simple code to integrate the mesh work with uBeDots, comparing it with like the sample codes that they provide in the documentation, like particle.
Okay, so the main challenge for the library is that particle mesh, like particle subscribe,
Okay.
expects an static type function. So to handle static stuff in C++ is a headache. It's a headache, and that has been the main challenge, because I need to make the library as easy as you are looking in this, but to the path to get in this case to just change ubimesh in the backend needs a lot of work, and that was the main challenge, to handle with static stuff and to avoid memory issues. That was the main challenge.
But actually, that's why we are here.
Yeah, exactly. And also,
uBeDots lives as a means to lower every IoT barrier for end users or
Exactly.
integrators. So we are here to ace this to our customers.
yeah,
right?
and to make it simple for you, as we already did with our platform.
That's,
So it's already uploaded.
yep.
So yes, there it is. So notice that in this case I'm having
Variable
as variable label 2.
Yeah.
Not just variable label. So
Uh-huh.
if I come to uBeDots, this variable is not getting updated. Look that it has just stopped, and I should have another additional variable, in this case variable label 2, and this one is the one that is being updated.
Yeah.
Nice. Nice.
So
nice.
if I need to change data to both variables, what should I do? Just copy and paste.
Yeah,
this
put
one.
that in between,
Yeah.
and that's it.
And
That's
it.
all.
One at a time.
Yeah,
That is
one
not
at a
the
time.
only way.
And
One at a time.
how many variables can I send in each loop? Does it
You
matter?
shouldn't send too many variables. So,
Okay.
for example, if you are going to send 10 variables,
Okay.
you should add a delay. Yeah,
Okay,
Yeah.
between each. It's important to keep in mind that.
it's very important, because this is something more related with the mesh rather than with particle. The mesh is from my test. I'm not sure if maybe I'm making something wrong. I'm not sure, but from my test, using mesh, I should handle the cloud connection, and that gives me limitation, because the mesh can be faster than the way that I send data. So that's a limitation. Not for a limitation for the mesh itself. It's a limitation of the whole architecture.
That's true.
Yeah.
Yeah, because sometimes mesh. Yeah, you already said it. Is faster than
mesh is too
waiting,
fast.
waiting for a reply from a server cloud.
Yeah.
Yeah.
It's
that
really
makes
fast.
sense. Uh-huh.
It's really fast. Mesh is really fast. It's a really fast protocol. So let's see now. What about using, for example, UV types or device type? Sorry,
Okay.
device types. So device type, you know that it's only supported using HTTP. Yeah. So I should set the gateway
To use
to
HTTP.
use HTTP. So I come here. I just set
Change
here
the
HTTP
protocol.
Uh-huh.
and just compile this one, and I'm going to upload this piece of code to the gateway, and also I need to make a small change in the mesh publish that I'm going to show you.
I
now,
have a
in few
question.
moments.
Can you go to the Xenon code, please?
To which one?
To the other one, to the other code.
The Xenon.
Yeah, and go up. Why is the reason that I have to have the uBeDots token in both code?
This one,
Uh-huh.
because this is a war. So what I'm telling here to the firmware is that if this variable, in this case uBeDots token, is not defined,
Okay.
just define it.
Okay.
Yeah, because this piece of code can be in a bigger piece of firmware code. So if any of that firmware that I don't manage, that you manage you as users, declares this variable, I will have here a conflict.
Okay.
So it may breaks the code. So that's the reason of this word. So I think that it's already set. So I'm going to change this.
We can check here.
I'm just going to comment this stuff. Sorry. I'm just going to comment this. And I have already prepared this one. So when I'm using device type, I need to use HTTP, and I need to also add this particular flag, which is the type flag, which is the type flag. So in this case, I'm going to create a device labeled as Xenon of type industrial machinery. That's I'm doing
type is the name that you are.
That time should match the name
type
that is already set here at uBeDots.
So it's important to clarify that the device type have to be.
The device type should be already created.
Exactly.
So in this case, is industrial machinery. So this device is red, and the variable colors are different. So it has a different logic than the default device. So if I want to publish from this particular node to create this particular device type, so I just need to add this, which is the same example that is already supported in the actual library, and that's all. I don't need anything else.
So it's really cool, that new method.
Yeah, while this compile and we flash it, I just like to always remind our users about what we're saying. Types is a way to easily manage and create devices with certain characteristics. In this case, I think this is really valuable because you are going to deploy thousands of these. You don't want to configure every one of them on uBeDots. So adding the type device, device type feature allows you to create just one template, device template, and then sending this, uBeDots will do all the work for you.
So let's
see here is connecting to the mesh.
It's already set. I'm just going to clear this output. It should be already created. I think so.
So now if we go to the device section,
to the mesh
we
network.
should see a new device.
Here. Is this still connecting to the mesh network?
A new request.
Let's just wait to connect. Is a new port?
I think that this is one.
But it's actually taking longer to connect to the mesh network. As you can see here, it's
blinking.
It's blinking green.
It's connecting. So in this case, it's blinking green.
I think you can
when
see.
When it blinks green, it means that it has not already connected to the mesh. So I need to wait. That is.
Adding value, finished.
So in this case, this is the serial output from the
gateway.
From the mesh, from the node. Sorry.
From the node.
So the gateway should be one of those. And just let's see. Okay, no, it has not sent anything yet.
This is really weird because
I'm not sure why it's not connected, but we need to wait until it blinks cyan. So
should I reset it?
No, it should not make anything else. So we can just wait. This is something that handles the party configure. So
well, guys, just like a reminder, if you have any question, again, don't hesitate and leave your question in the comment section. We are here to answer all your doubts. This is the best place for have like a direct contact with us. So yeah, we are here to help you.
So this is already connected, and this is connecting.
Now
we're going to have it. Here is cyan.
Yeah, it's cyan. So just let's wait 20 seconds.
Let's wait 20 seconds, and that's it.
That's all.
While we wait, as Maria was telling you, this is the best place to reach out to us, but also you can write us to support@uBeDots. I'm actually the one always behind that channel, together with our support staff. So if you have any questions, troubles connecting to uBeDots, using, of course, Particle, because we are here for that, don't hesitate to reach out. We will be glad to help you out.
So in this case,
do you have
publishing.
HTTP?
It's already publishing, so.
But
I think that it seems
it's not
that
working the type.
It's not working the type. Maybe I'm going to choose this one again. I'm going to let's just upload it because it didn't upload the firmware. I don't know why. Okay, but this is something that sometimes happens when in my test when I try to upload a firmware of a node using mesh. Sometimes I don't know why
it doesn't upload the actual.
Yeah, I don't know why. Let's wait.
So let's give it a second try, and if not, this is going to be something we need to work out.
It's already uploaded. Let's wait.
It's already connected. It's actually already connected.
Yeah, in this case, it's now the firmware is already uploaded. So
Cool.
notice that
you have the type there.
Yeah.
you
Do you
have
see type?
in this here you have the type.
Exactly.
Yeah,
Exactly.
and I'm using HTTP. Notice that I also changed the
gateway
gateway
firmware,
Yeah.
and
Yeah.
it's using HTTP. So this is a different server answer from the last one. This is an answer from HTTP. So it should already be, because here I'm getting a 201
status
response code. So I should already have created here.
And here we
there
have
is the
and
sign-up.
it's red, and it has all.
And it have all the
values.
variables that are, of course, I'm not sending current and UBT and power and
Yeah,
so
that
on.
is
So
one
that's
of the device type templates
Yeah,
that
that's
was
the
already
device
created in
template.
the account. So
I'm just sending variable labels. So
That's nice.
that's all.
That's really
But
nice.
that's the way that we are implementing the library. It's already, as I told you, as a release candidate. So I'm just performing some additional tests during this and the other way, and I hope to release this soon at the beginning of April.
Yeah, beginning of April.
Yeah.
Perfect.
So guys,
one
last thing about Maria's going to share with you, I think, a coupon code.
Yeah,
the nice part of
exactly.
the
We have this coupon code for you guys, so feel free to claim it. Well, guys, is the principal one here. Here we are. Okay.
We are back here. I hope you enjoyed the uBeDots live here. Enjoy the coupon code. Go redeem it on your billing and plans section from your uBeDots account. If you have any questions, doubts, inquiries, please don't hesitate to reach out. We will be glad to. Dave Kinney. Dave Kinney just wrote. I remember you, Dave. I've been watching your ticket for 2 weeks, and I have been snoozing it because we wasn't ready. But please know the uBeDots library for mesh devices is on the way. This is a release candidate. I hope you enjoyed this Facebook Live, and I want to know what is he saying.
The most recent library in the particle ID is the 304. Will the RC be in the particle ID or only on GitHub?
Actually, we can put it on GitHub. If you are able to use the CLI from Particle, you can compile it locally and have access to these new methods. But right now, it's not published on.
It's not yet published
on the IDE. You will still see the 304 version. Once we do all this testing and QA and ensure is everything working fine, no memory leaks, and we sort of learn about the frequency, about message, we're going to release it and upload the version to the IDE. But right now, you can compile it locally. Just zip it down, and that's it.
Yeah,
I think you can use this CLI.
Perfect.
If you guys think this is ready.
We don't have any other questions. So this is everything. Well,
really nice.
Thanks for joining this uBeDots live session. If it has David already said, if you have any other question, just contact to uBeDots team through our media channels or support that ubidots.com. and we are here to help you to build all your IoT solutions.
Bye bye.
Bye bye.
Bye,
See you
guys.
next time.
See you next time.